All right, let's get started. Thanks everyone for braving the rain to come to Geolunch today. And thanks to our special visitors. We have Danielle Golon and Sydney Neely from USGS, NASA's LP DAAC, and Danielle will tell us all about the DAACs, so I'm not going to go into that. These guys have been really kind. They're traveling well, Danielle's from Minnesota, and Sydney's coming from Sioux Falls, South Dakota, to be with us and give us some information about some of the great tools that NASA has. As I think many of you know, they are going to be here tomorrow also to be teaching a hands-on workshop in the GIF on using these tools. So I hope some of you have signed up for that. I know it's tough on a Friday afternoon before Thanksgiving, but there are still a few empty slots if you're around. I think it'll be a really great resource for learning some new tools for everybody. And with that, thank you so much, Danielle. Thanks for coming.
Perfect. All right. Hi, as she mentioned, my name is Danielle Golon, and I'm the Science Communications Specialist for the LP DAAC. Has anyone in here heard of the LP DAAC? All right, perfect. We got a couple of hands. Has anyone used like MODIS data, Astra data? A couple more hands. Okay, so that's data distributed by the LP DAAC. So today we're going to cover what is NASA's LP DAAC, what types of data are publicly available, what does the LP DAAC website have to offer, and then I'll do a live demo of two of the tools that you can use to access the data. So let's jump right in. So what is NASA's LP DAAC? Well, we are the Land Processes Distributed Active Archive Center. You're going to learn that we love acronyms. We're located at the USGS Earth Resources Observation and Science Center in Sioux Falls, South Dakota. That's actually where we live and work. And then a couple of us work remotely, so I work in Minneapolis, and we have a couple other around the country. And the LP DAAC was established in 1990, but AROS itself was established in the 1970s. So there's 12 Earth Observing System Data and Information System, or EOS DAACs, and they're part of the NASA Earth Science Data Systems program. And some of the DAACs cover like snow and ice. There's one in California that covers ocean biology. Another one covers socioeconomical information, but we specifically work with land data. And our vision statement discusses advancing the access, understanding, and use of land remote sensing data. So what does that mean? Well, we process some of the data, we archive it, we distribute it, and we also like to show users how exactly to use and understand and work with and apply the data. And we provide data to hundreds of thousands of users. They range from professors and students like yourself to archaeologists, meteorologists, all sorts of people you can see in the graph. And we've distributed over 17 petabytes of data to these users and have archived over 3 petabytes of data composed of 260 data products. And we have a lot more coming over in the next week, next couple of months, and even the next couple of years. And most importantly, all of this data is publicly available at no charge, freely available, so you can go out and grab all of it. So some fast facts about the LP DAAC. Our archive extends from 1981 to present, with many temporal resolutions in between. And then we also have, it ranges from 15 meters. As we can see this image on the left, this is a mega solar park in India at 15-meter resolution, and then all the way up to 5,600 meters covering the entire Earth in one day. So the data products we offer cover a variety of topics, including land surface, vegetation, elevation, and more. Today I'm going to focus specifically on these categories. If you are working on something that's not in these categories, feel free to talk to me after the presentation and I can kind of help you and see if we have any data available for you. So where do these data come from? Well, our newest sensor is the SNPP VIRS, or VIRS, which is on board SWAMI. It's a continuation of MODIS, which is a continuation of AVHRR. So we're seeing continuously capturing data, larger picture with less detail. So if you're thinking about, like, if you're going to mail a letter and you have the envelope, this is going to cover the entire envelope. Then we have the MODIS sensor, which is on board the Terra and Aqua satellites. And again, this is similar to VIRS, continuously capturing larger picture, lower detail. And then we have the Astra sensor, which is on board Terra. There's a tactile sensor that has to be turned on. So we're seeing higher detail, but in a smaller area. And so again, if we have that envelope, we're just getting the postage stamp. We also have our NASA Measures products. These are projects that expand our understanding of the Earth through using our existing satellites. So I think this is really cool because we're basically recycling data for a new purpose. These products cover emissivity, vegetation, and land cover and elevation. And we also have a couple more coming literally in the next couple of weeks, and a lot more that are coming this next summer and beyond. And then we also have community products. These are derived from one or more NASA Earth Observing System, or EOS, missions. They cover currently ASTER global emissivity, but we are getting more in the future as well. And don't worry, I'll go into more detail about these in a second. So looking at our spatial resolution, as I mentioned, it's 15 meters all the way to 5,600 meters, and from daily all the way to annual and everything in between. Okay, so I'm going to cover the VIIRS, MODIS, and ASTER real quick, and then we'll dive more into the data. So VIIRS stands for the Visible Infrared Imaging Radiometer Suite. It's on board the Suomi National Polar Orbiting Partnership satellite. So it's a joint partnership between NOAA and NASA. And it was launched on October 28th, 2011. So data is going to be from 2011 to present. It captures the Earth twice a day at about 824 kilometers or 512 miles above the Earth. So it allows for little to no gaps that you might see when you work with MODIS data in the equator. And the VIIRS products distributed by the LPDAC are specifically products made by NASA. So while it was a joint partnership, we're specifically the NASA side. So as I mentioned, it's collecting from 2011 to present. We currently distribute surface and fire VIIRS data products, but we have a lot more coming along the way. And these are archived as an HDF EOS 5, but we offer a lot of tools where you can make it into a GeoTIFF or a different kind of format that you're more familiar working with. And I'll make sure you guys get these slides as well. Then we have the MODIS sensor. So this is the Moderate Resolution Imaging Spectroradiometer. Told you guys we love giant acronyms. It's on board both NASA and Terra's Aqua satellites, as I mentioned, Terra was launched on December 18th, 1999, and Aqua on May 4th, 2002. So our data is going to be available from those time periods. It's similar to VIIRS, as I mentioned, but it captures the Earth every 1 to 2 days instead of VIIRS capturing it twice a day. And so as I mentioned, these data are available from 2000 to 2002 respectively, and they're offset. So they capture the data within 3 hours apart, and it's helpful for capturing images of fire, hurricanes, volcanic eruptions, things with clouds, because we're getting to see that same area twice a day with a different view. And then it provides a lot of information on different environmental variables, including vegetation, temperature, fire, land cover, emissivity, and more. And we'll cover those in a little bit. And then it's also archived as that HDF4 file format. And if you're not familiar or comfortable with that, you can download as a GeoTIFF as well, or we have tools where you can convert it to a GeoTIFF. And then finally, we have the ASTER sensor, which is on board Terra, the same satellite as MODIS. ASTER is a partnership between NASA and several Japanese organizations. And it captures with 3 telescopes, which means it's pointable and taskable. So first we have the V-near, or visible and near infrared, at a 15-meter resolution. This captures both nadir and then also has a backward-looking band, so we can capture elevation data. Then we have the SWIR telescope, which is a 30-meter resolution telescope. It actually ended in April 2008 due to an anomaly on the sensor, but the data provided prior to April 2008 is still valid, still good. It's frequently used in geological applications, so if you are interested in that, definitely check it out. And then we have our TIR, or thermal infrared, which captures data during the day and at night and also provides thermal data. So Terra ASTER is collecting since 2000 because it's on the Terra satellite, and we have 3 million scenes and 515 scenes a day, and that seems really small when MODIS is capturing about 16,000 scenes a day. So as I mentioned before, the reason for this is it has to be told to turn on. And it can be turned on as an expedited product, meaning you'll get that data back within 24 hours, sometimes up to 48 hours, just kind of depending on what's going on. But then it can also be told to turn on, and as it's going over an area, it doesn't have to be directly over it, because the sensors are pointable, meaning it can be going over and near a volcano and then kind of point to the volcano to capture it. And one of the most important things to talk about today is that obviously you have to pay for ASTER over scenes not in the United States. As of April 1st, 2016, all of the data is available to the public at no charge. So yes, I see people in the back are excited about that. And it's going to provide a closer view of that data with different environmental. Yes? April 1st, 2016.
So people thought it was a joke?
People actually did kind of think it was a joke. We had a lot of people email in, but it was just kind of an agreement that they had with Japan where they don't really have April Fool's Day. It was kind of interesting. We all had a good laugh about it. But no, it is still freely available for sure, not a joke. And these data are archived as an HDF4, but again, we offer tools and services to download as a GeoTIFF. Okay, so now that we've kind of covered those, we're going to talk more about these specific categories of data. So first we have land surface data. This provides us a visible image of the Earth every single day. It can be used to observe natural or human-made changes over time, such as urbanization or farming, or to study impacts from natural disasters. In these images right here, we can see the web-enabled Landsat data set product, and this shows a farm from Stewart, Nebraska. So here we have a winter scene, a spring scene, a summer scene, and an autumn scene. And these are, one of the products is a seasonal composite. So that's what we're looking at there. And this has not been corrected for effects of atmosphere. But we do offer data tutorials that help you correct for it. The image on the right shows an example of the MODIS surface reflectance product. And this shows hail damage over Maryville, Missouri from a hailstorm. So we can see some of those hail scars on the data. And MODIS data has, in fact, been corrected for the effects of the atmosphere. Next, we have vegetation data. So vegetation provides us with information about the health of vegetation and the amount of vegetation on the Earth. Recently, MODIS data are used to update the Montana Climate Atlas. So we can see the image on the left is an example of the Montana Climate Atlas using the Normalized Difference Vegetation Index. And we also write data and action stories, which I'll cover a little more later, and that's an example from one of our data and action stories about how they actually ended up using the data. So if you're interested in that, you can read through it and learn exactly what they did. And then the image on the right shows the same cropland damage that we saw earlier with the surface reflectance, but using the leaf area index product. So again, we can see the hail scars. And this data product is looking specifically about like, the amount of canopy leaf coverage in the area. Is a good way to kind of summarize it. Okay, so next we have elevation data. So elevation data can be useful in identifying where watersheds are. For example, in this image, we can see where Lake Oroville, I hope I'm pronouncing that correctly, in California is located. We also have people who have used it to understand volcano lahars in Mexico, understand if a volcano erupts, is the city of Pueblo, Mexico is the example, is there a chance that they're going to have to move quickly or get destroyed by the volcano lahar? So it's used for modeling that, and also to help identify what types of crops can grow where. Certain crops need a certain elevation to grow. And one important thing to note here is that the LP DAAC distributes a freely available global elevation data product at no charge. So that's the example we're seeing here. It's the Aster GDEM version 2. It's available from 83 degrees north to 83 degrees south, so we get a wide range of data where you're not going to have to pay for it like you will with some other sources. And with version 2, there are some redistribution requirements, but version 3 is coming out in mid-2018, and that will do away with all those redistribution requirements. And I'll kind of talk more about those when I talk about the website. So then we have land cover data. Some of our land cover data products include information about the different types of land cover over an area. So here we can see a transition in the Dakotas. So up here is going to be where North Dakota is, South Dakota is going to be here, and then Minnesota is going to be over here. So we can see a transition between the different types of landscape. And this is actually the Black Hills Forest where like Mount Rushmore is, if that helps you guys. And so as we're transitioning over, we can see changes until we get to a forested area. So this is going to be more croplands, and this is going to be more of the grasslands area, if you can't see in the back.
Would you send people more to the national map to get finished products? Did you do raw, or how would you get those?
It kind of depends what your comfort level with the data is and what you're planning on doing with it. We've worked with the national map. They use a lot of our data as their inputs. So if that's something you're interested in, you have that option as well. And then our other land cover data product that we provides information about dominant crop in an area. For example, here we can see like wheat and rice, or if it's corn and soybeans, and also how those crops are being watered. is at 1,000-meter resolution, so it's kind of going to be for larger swaths of area. And we just newly released a GFSAD product. This is called the Global Food Security Support Analysis Data, or GFSAD. And these are data products that show cropland extent. So in this image, we have the Amazon River, and you can see the green is cropland around the river. And this one is divided into the Earth into 7 different regions at a 30-meter resolution, so a much finer resolution. Next, we have temperature. So our temperature data provides specifically temperature about the land's surface, so not going to be the air above it. But it's useful in understanding a historical record. We have data temperatures for day and night. So a lot of people use those to study during times of drought and add that as a key factor. It can also help with studying key islands. In this example, we have New York City and the island of Manhattan, and you can see where Central Park is easily on the map, showing an area of kind of relief from the heat for people in the city. And then the top image shows temperature in that same region before the Dakotas and Minnesota. So here we can see the Black Forest is going to be really cold, or not really cold, but you know what I mean. Whereas the areas around are kind of warmer, and as we're transitioning towards forested areas in the Great Lakes, we're seeing cooling. And then we also have climate modeling grid products. We have these for several of our products, not just temperature. So we have these also with surface reflectance and a couple more. And this provides you with all of that data of the Earth for one day at a 5,600-meter resolution. So you're getting the entire picture in one day. And then finally, we have fire data. So fire data helps us understand where fires exist and can also help us actively monitor fires both thermally and visually. So this can aid in understanding where it exists and where it might spread, which is definitely helpful for you guys. And it can also help first responders understand where those fires occur, where they hit the hardest, where they need to send the most aid, and building a historical record as well. So the image on the left shows the burned area product. This is a monthly product. You can see this is the Idaho, this is the Pioneer Fire in Idaho. The red is where the fire started, and it spreads out to the blue is where the fire grew over the month. So it's really interesting to be able to observe those burn scars. The middle one shows the area of northern Florida during the month of February from 2017. The red dots are going to be fires that existed during that time. So if you're interested in fire data, we definitely have a lot that can help you. And then we also have our Aster data. So again, we're seeing that finer resolution. This is the Jasper fire in the Black Hills of South Dakota. And we can see the big burn scar. And then we can also kind of see where the fire still exists and the smoke coming off of it. Yes.
So we just had some big fires today. Does that data come out right away and to the public, or is that held on for a while?
No, it'll come right out to the public. As soon as the data is ready, it's uploaded to our website, and you can download it from the data pool or any of our other data access tools. And I know Aster was tasked for a lot of fires in California recently and others throughout the states near you guys, and that data is available too. It's kind of difficult sometimes with the Aster because it'll be just full of clouds, and there's nothing you can really do about that with smoke and everything. But I'll show you eventually how we can search for Aster data on one of our tools so you can preview it. Okay, so now that we've talked about the data products and the data types, where can you find out more information about the products? Well, the best place to start is the LPDAC website, and it's where you can find anything you need to know. So we're going to dive right into a live demo. And we don't have any maintenance going on, so I'm hopeful that this will work. Perfect. Okay, so we have the About tab. The LPDAC website is lpdac.usgs.gov. We have the About tab, which tells you all the information you can ever want to know about the LPDAC. We have the Dataset Discovery, so if you know exactly what satellite sensor you want to work with and you're just ready to jump right in, you can go there. Or if you have no idea what any of those words mean, you can go to the Dataset Discovery option. And so here you can search by what kind of information you're interested in. So let's say you're interested in vegetation indices data. You can just click on it, and this will filter out and show you just the vegetation data. And then you can search by temporal granularity, dataset version. We recommend, with MODIS, we just reprocessed to version 6. So we recommend people use version 6, as version 5 stopped processing in March. So data ended at March for version 5. So definitely check out version 6. And then this will tell you the name of the product information. So this is our vegetation indices, the satellite sensor, the data set, the version, if it's a composited or a daily image, the pixel size, spatial extent, all that cool information. So we'll go ahead and open up one of these pages. And this is going to be the DOI landing page. Perfect. All right, so on this page, you will find out every single thing you want to know about your data product. And every single data product we have has a page that looks exactly like this, but is just filled in with the corresponding information. So we have a description of all the data. We have any improvements or changes from the previous version when we reprocess the data. We have a citation information, so who the POI was, or the PI was, and then what the DOI is. A lot of people like to use DOIs for citation. That way it just always links back to this product. It's easy to find it. And we have a citation generator, which is super handy to help you figure out for your papers. Just plug it in and go. And then we have information that includes the data characteristics. So this is going to tell you about the temporal granularity, the temporal extent, spatial extent, all that good information. And then I'll also tell you about the a specific granule. So here we can see these are going to have 12 science data set layers. And then it's going to break down these layers. So when you're entering, when you add this to ARC or your favorite GIS program and you have to pick what layers you want, you can go back to this page to reference what exactly does that layer mean. So it has the name, the description, what the units are, the data type, the fill value, valid range, and scale factor if those are available. It also will include product quality information and any known issues with the data. And then also documentation. So we have the user guide. So this is updated frequently if there's any issues with the data or if it goes through a reprocessing or anything. And then we also have the algorithm theoretical basis document. This is the ATBD. Once this is made, it's never touched again. We have a lot from like 1999. And this explains the algorithms and science that went into making the data. We also have our tools section. So this shows the tools that you can specifically find the data that you're looking at. And then we have our e-learning table, which I'll show you the full table later, but these are the specific e-learning items that relate to this data. So we have video tips like choosing a data access tool. We have previous webinars. We have data tutorials and R scripts if that's your thing. From the website, we can also see citation information. So if you use our data, we do prefer that you cite it. So this will give you a description on how to cite tools, how to cite any scripts or tutorials you've used. I'm gonna wait for it to load. Oh no. Let's see, I'm still connected. Okay, well, the citing our data, we'll see if the tools page works maybe. Uh-oh.
The child visitor might have some restrictions somehow. It's just
It worked over earlier, I promise. Do you have any questions in the meantime? Yeah, sure.
So it says, the login in the upper right-hand corner says sign in with, log in with Earth data.
Yes.
And I recently renewed a credential, and can you say anything about that?
Yeah, so Earth data, you don't actually need it to use our website. It's just there for ease later on when you're using the tools and downloading the data. But Earth data is a freely available NASA account, and it's basically a way for us to use metrics to understand how people are using our data, how often data is being downloaded, what are the most popular products, which can help us later understand which products should we improve, which products did people like the most, maybe we should make more vegetation products, that kind of stuff.
Specific to NASA, or is it shared with the national map?
I don't know about the national map. I know for all NASA tools you have to use it. I'm not sure about national map though, but I can find out for you. Okay, so citing our data page. So this will show you how to cite the tools, and then also how to cite the data, and then if there's any special citation requirements. So as I mentioned with that Aster GDEM, the elevation data, when you download this data as a partnership with Japan, we had to determine what are you planning on using this data for? What's your field of research? So do you research health? Do you research natural disasters? That was just something they were interested in knowing. And then you also have to agree to say that Aster GDEM is a product of NASA and NUTI. Okay, so back to the tools page. So we offer a wide variety of tools. Some people say a little too many tools. but you have to figure out which tools work for you. We have tools for people that are completely basic, have never used GIS before, and we have tools for people that are just, they've got their script down, they're ready to go. So today I'm going to show you 2 tools, and we'll cover those in a second. And then our user resources tab. So we have our publications table. This is a publications table that's updated quarterly. So we're currently updating it all the way through to October of 2017. So if you're looking for any journal articles, book selections, conference papers of how people are using our data, or just to help you with your research, maybe if you're using NDVI data and you need more resources, this is frequently going to be updated and a great resource to check out. We also have our data and action stories. These are stories that we write in-house about different ways that people are using our data or ways the data could be used. And we have, you can see we've covered a large portion of the earth with our stories. And if you are using our data and have any cool use case examples, please feel free to reach out to me because I'm the one that writes most of these. So I'd love some more content or some more ideas, and I just get excited hearing about people use our data. Then we have our e-learning tab. So this is the table that was connected to that DOI landing page I mentioned earlier. But here you're going to see everything we have. So we have data visualizations. These are just kind of cool, pretty videos showing how to use the data. So examples of like land surface temperature data, those kinds of things. We have previous presentations that we've done. We have data tutorials. So again, those are those R scripts and different types of tutorials and Jupyter notebooks that are made in-house at the LP DAAC. And then we have video tips. So we have been really moving into the video age and turning everything into a video. So we have ways to explain what does quality information about vegetation data mean and how can I understand it, things like that. And then anytime we give a webinar online, we also post it here. So if you missed out or didn't know about it, you can still view it. And then last, we have our user services tab. So our user services team are in-house people that can answer your questions. They're live, real people. And if they don't know the answer, they can find scientists in the building or other people like Sydney and myself that might know the answer. Okay, so with that, we are going to jump into our tools demo. The first tool we have is Appears, the application for extracting and exploring analysis-ready samples. Again, we love big acronyms. All right, so what I've done is we're going to look at all of CONUS. We want to look at the LST, NDVI, and snow cover for all of CONUS. And if you're processing that by hand, it's going to take a lot of time, right? So this is kind of a way to make everything smooth and efficient. So first we'll show you an area product, and I'm going to copy a previous request. If you're doing it your first time, you'll start a new request, and it will look the exact same. We'll just have things filled in for the sake of time. So first you're going to name your product, and when you download the data, it's going to have this name attached to it. So pay attention to what you're actually naming it, and don't just throw in some random characters or something. So we'll call this Area CONUS GIF. And then here you can upload your own polygon vector files. So let's say you work with national parks. You can upload one file that contains all the national parks you work with, or you can upload a single polygon, or on the right-hand side, you can go ahead and draw a polygon or draw a rectangle around your study area. Then you can select the start date. So here I've selected September 1st, 2015 to September 1st, 2017. And if you work just in the summers or just in the winters or a specific time frame, you can do the dates reoccurring. And then we'll add a layer. So let's say that I don't actually want this NSIDC snow cover layer. I can just remove it. And then if I realized, oh yeah, you know what, I actually did kind of want that layer. We can search for, you can search for the short name, you can search for snow, you can search for keywords, and it'll pull it up. And then you just have to be careful about which one you select. So we're going to pick the daily version 6. And it will tell you that version 5 for them ended January 1st of 2017. So this will tell you this information is still present. And then we'll add that snow cover back in. And then you can select the file format you want. So if you want a GeoTIFF or if you want a NetCDF4. Some people prefer NetCDF4 because it's a little smaller file size. And then for projections, you can choose how you want it projected. So in its native projection, geographic, we have a couple others. These are ones that work really well with the data that's currently in Appears. We're frequently adding more data. So all of MODIS is in Appears, all of VIIRS. On the website, there's a section where you can choose to see what data products are in the tool. And if there is data that's in the tool or that's not in the tool that you want, you can reach out to us, and that's definitely one way for us to understand what do people want, and you might be able to see it in there later on. So then we'll submit. And at the top, it'll tell us it was successfully submitted. And so then right now, I'm getting an email that says you have submitted your order. And as soon as the order has been completed, you'll get an email that says the order is complete. All right. So then we go to our Explore tab, and we can see that the order is running. So CONUS is kind of large. When I ran it a couple of weeks ago, it ran from 3 p.m. to 6 a.m. So I just, as soon as I was getting ready to get off work, ran it. When I showed up the next morning, it was ready to go. So since I ran it already, I'm not going to make you guys wait, 12 hours or whatever. So we'll go ahead and explore.
So running on hardware at your aerospace center, or is it all cloud center?
It is, yeah, it's all cloud.
Spin up stuff and
Mm-hmm. Yeah, and it also is helpful because as someone else runs the data set, then it's going to be saved in the cloud, so it'll be faster each time. So let's say we're interested in NDVI data for CONUS. So now here at the bottom, if my mouse will work for me, there we go. So you can see here we have a box and whisker plot showing the NDVI values. And we can also say, I'm just interested in a specific time frame. You can click, and then it'll change to filter to just those values. So this is a great way to explore your data values before you're working with the data. And you can also change it if you just want to look at a specific year, or even if you want to filter by the y-axis. And then below, it's going to show the decoded quality information from the ModLand bits. So this is going to show, let's see, we'll reset this and look at all our data. There we go. So here's all the data quality information you're going to get from your order. And it'll show you exactly what this means. So we can see blue means VI was produced with good quality and it's the highest quality. Orange means it was produced with good quality, highest quality, ocean coastlines and lake shorelines, whereas this one was specifically land. Okay. And then if you want to go ahead and download this data, we'll move to the download section. So you'll download it, and then it'll bring up this page. So here's the metadata information. So you'll receive an XML of the metadata information. You'll receive the data pool URLs for the source granule. So every single granule that this is reading, you're going to have access to see that granule. So there's no guessing about what went into this. There's also going to be a README text file that explains instructions and details about the request, and a JSON file. So I'm currently in California. If my coworker in Sioux Falls is like, oh, I really need you to look at this request right now, can you check it out? They can just send me my JSON file, I can run the request, and then I can view exactly what they're viewing and talk with them about it. It also has the statistics information for the quality layers and lookup values for the quality bits, so decoding that quality information for you. And then at the bottom, it has the mosaic geotiffs. So this is going to show quality information, but let's say I want to download my Mod 13s. So this is going to be 1 day of vegetation NDVI in CONUS in one mosaic. So I just ran it overnight, didn't have to do anything, saved me so much time. All right, so now let's do the exact same thing, but let's do it with points. So we'll move to the point sample. And again, I'm going to copy a previous request, but it will show exactly what the start a new request would show. And we'll call this CONUS points GIF. And then you can upload a CSV file with your coordinates, or you can manually enter them in. You only are required to enter in the Latin long, but you can enter in an ID. So I like to do 1, 2, 3, 4, 5, so it shows me where my places are. And then you can do categories, which I'll show you why you would want to do that in a second. And then we'll have our start date. So we have September 1st, 2015, end date, September 1st, 2017. And on the map, I can see where my points are. So if I zoom in, I can see where my points are. And then it'll be the exact same layer structure as before, so selecting the layers that you want. And you'll notice here we're not going to be able to do any reprojections. This is because this is going to give us a CSV file and not any like mosaic geotiff or anything. So we'll go ahead and submit that. And then if for some reason it didn't submit successfully, it'll tell you up here what went wrong, so you can go in, fix what happened, and change it. Frequently it's the dates are wrong, so one's like the date starts before it ends, or ends before it starts. There we go. Okay, and so then we'll go into exploring this data value. And so here we have our points. So I'm going to pick, let's say, cropland. Let's see where this cropland is going to be. So I can zoom out, and I see it's Emporia, and I'm from Kansas, so I know that this is going to be in Kansas. Perfect. And then we'll look at that NDVI values again. And here it's going to pull up a graph of the values. You can add a line so we can explore. You can zoom in, zoom out, so we can see exactly the time frame that we're specifically interested in. And it'll also have a stacked time series below, so we can observe how the NDVI changed over the summer. So in 2016, we saw kind of a dip right before June. Maybe there was a late snowstorm. We'll have to look more into it. Whereas 2017, it was more stable. And then below, it'll tell you the date of the data, the exact NDVI value, and then the quality information. And with points, we can do a cool option where we change and say, I just want good quality. So now it's going to filter out and remove all of the bad quality data, or not good quality data, I should say. Because there's different types of, yes. And then we have a layer comparison, so we'll go back to that cropland again. And we will see, let's see, NDVI versus LST daytime. And so then we can compare the two. So we can see, yep, when it gets colder outside, NDVI values are obviously going to dip. When it gets warmer again, they're going to grow. And we can see that over a scatter plot. And then we can also compare the exact values over here. So we can see the exact day for both granules, what the NDVI value was, and what the LST in Kelvin was. And then finally, we have categorical overview. So this will show us, we'll pick that NDVI again. And this is going to show us the quality information with box and whiskers. If you don't know what 0, 1, and 2 means, you can just click on this eye, and it'll tell you exactly what that means. And then you can also click and filter through. So if I click on this, I'm just seeing good quality data. And here's where the categories help. So here's cropland, desert, forest. So it groups my areas in together for me. And then below we see the sites. So this is the numbers that I associated with it. So I can filter those two to just show cropland data. And then the NDVI values. And then when you want to download the CONUS data, let's see, CONUS points. Perfect. So we'll download. So this will actually download a zip folder for you. Let's make this big. And so this will give you, again, a granule list, so you know every single data granule you're getting. Metadata information, the results in a CSV file. Open this up for you guys. Maybe. And then the JSON file and the README text file. And then the last tool I'm going to show real quick, if I have time, is Earth Data Search. So do you guys use Reverb at all? Okay, I have terrible news. Reverb is going away. At the end of the year, it is gone, and Earth Data Search is going to be the tool that replaces it. It's a little flashier, fancier, kind of an easier interface to work with. So for Earth Data Search, let's say we're going to look at Aster L1T, our level precision terrain corrected Aster data, and we're going to look at it over the area we're around now. So we'll zoom into our area. Let's see. So let's say we want to see all the data right around here, just kind of around the area. So I can draw a polygon or a rectangle, whatever I want. Let's see, I gotta move this guy down. Yes, and so this you can move up and down so you can see more, see less. Okay, and then I'm going to type in Aster L1T. Again, it is keyword safety, so you can just type in vegetation. I'll pull up all the vegetation products, but this has way more than our data, so it's going to pull up a ton, so that's why I search for short name. And then when you click on it, we can see all the granules that exist within the area. This green is going to show the footprint of the actual scene or granule. And then here we can see some thermal data. So let's say I don't really want that. I just want to have visible data. I can filter. and I can choose day only and apply. So it's going to get rid of those thermal data, and let's say this one has a lot of clouds coming off the ocean, so maybe that's going to impact my data. I can just get rid of it. And then you can select which ones you want. And if you want to know more about the data, you can click on this eye, and it'll pull up all the metadata information right there. So definitely helpful. And if you also want to learn more about Aster, you can click on the Aster L1T View Collection Details, and this will pull up which DAAC distributes it, where was it created, what goes into this, what is this, when did it start, those kinds of things. And then you can download the HDF individually, just ready to go, or you can download and customize your data, or you can say you want to download all the data. So we're just going to go ahead and download all this data. And I can see it's 737 granules and 123.2 gigabytes. I don't really have that space on my computer, so I don't want to direct download, but if you have just a couple of granules, you can direct download, and I'll just give you a list of the HDFs, and then you can click on them to download or run a script to pull them all, or do a download them all tool in your browser. You can also stage for delivery, so this will email the files to you. And you can choose, so with Aster L1T, it's a GIS ready product, so in addition to getting an HDF file, it also comes as a full resolution browse GeoTIFF. So great for just plug and play if you don't really want to worry about all the HDF business. So I can say I want all my files, or I only want the full resolution. And you can say if you want any quality assurance or browse files. You can also customize your products. So for certain data products, like with the fire product, it'll let you choose, do you just want the fire mask? Or with vegetation, which vegetation product do you want? Which vegetation layer do you want? For Aster L1T, it's just, do I want a visible, thermal, or all full? And then you'll continue, review your information, and then submit, and it will submit and email this data to you. Super friendly, super easy. It allows you to visualize the data ahead of time, which is great for certain products. All right, so then let's go back to okay, so I realized that was a lot of information in a short amount of time. I just want to make sure we covered everything. If you do have questions, please feel free to explore our website. You can reach out to our user services team. You can email directly, play around with peers, check it out. Other than that, I have fact sheets, I have bookmarks. If you want to join our listserv, you can just sign up here and I'll enter you in. It's a thing that we send out about twice a month that talks about new data products and data products, new data tools, how people are using our data, data tutorials, that cool stuff. So with that, I'll leave the contact information up and answer any questions.
Thank you.
Yeah, thank you.